Good. No, just kidding. All right. Find derivative function, add a number. Find the derivative of this at f prime of 2. All right. Y'all already know this. What's the derivative of the function first? 4x minus 3. So now what is f prime of 2? Right? Okay, so far, these are actually very, very good to go over because if you think of these as the concepts that we're learning, you'll be like, oh, okay, I got this. All right, so far I've given 3 interpretation derivatives. Geometric interpretation. If y equals f of x, then the derivative f prime of c is the slope of the tangent line to the graph of f at point c, comma, f of c. That's the x and y values for that certain point that I'm plugging in, right? Yes. Good. All right. Rate of change of a function interpretation. If y is equal to f of x, the derivative f prime of c is the rate of change at f, which is basically rate of change is slope. Yes. Thank you. Physical interpretation. When distance s at time t of an object in, I don't want to say that because it sounds weird. Rectilinear? Wow. Rectum. Ever almost killed him. All right. Okay. Motion is given by the function s equals f of t. Then derivative f prime of t sub naught is the velocity of the object at time t sub naught. So, what does that mean? When you take the derivative of the position, you get velocity. Thank you. If you take the derivative of the velocity, you get
acceleration.
Okay, and if you take the derivative of acceleration, you get the
Chacho.
I was waiting for that one. Okay, we get someone that's texting during my lesson, but it's all right. Okay. Wow. Why do you think it was you?
I don't know.
Okay.
I honestly thought it was me.
Okay.
I'm not even texting you though.
Okay.
I thought he was
Okay. Anyway, all right. It's right under that, so you only lift the first one. Yeah.
Well, I assume that there's someone else's name.
Yeah. 6 still has not made me a thing for the thing for second hour. Okay. All right. Find the derivative of the function here at x equals 8. So you guys already know the process for derivative, don't you?
Yeah.
Okay, so I'm going to kind of breeze through this because you already know this. So f of x equals, I'm going to rewrite it, 2x to the 1/2. Now, if you write your radicals as exponential equations, exponents, it makes it a whole lot easier, okay? Whole lot easier. Okay, so now let's do this. What rule would I apply here?
Chain rule.
Thank you. So, derivative of the outside is? Okay, so now, here, even better. Tell me what I should have. 1/2. 2x.
Times 2.
Okay. Negative 1/2 times derivative of the inside, which is 2. Right? Okay, so I'm going to do some cleaning up, right? So if I clean up and blah, 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 that goes down. So what's left on top? Okay, so it's going to be f prime of x is equal to 1 over. So it's going to be 2x to the positive 1/2, because that goes down, right? Yes. Now we're plugging in x equals 8. So if I plug in x right here, if I plug in 8, so f prime of 8 is equal to 2 times 8 is 16. What's the square root of 16? 4. 1 over 4. So the slope at 4, or I'm sorry, the slope at 8 is 1/4. Yes?
Yes.
Good. Now, we have right here, find the derivative here to find the equation of the tangent line of the graph here. So, we're talking about tangent, not the normal. Okay? Normal, I would use what? Very good. Opposite reciprocal. So now I have the tangent right here. So let's go ahead and just plug in my values. So it's going to be y minus 4 equals 1/4 quantity x minus 8. Y minus 4 equals 1/4 x minus 2. Add 4 to both sides. Y equals 1/4 x plus 2. Jess? Good. Approximating derivative of a function defined by a table. Table below, several values in here. Values of the function y equals f of x. That is continuous. What does that mean if it's continuous? There's no holes, right? No hole gaps, jumps. It's all going to be continuous there. Okay, on the interval from 0 to 4, approximate the derivative of f at 2. So if I'm going to approximate the derivative, what could I do? I could do the secant line, right? I can do a secant line, but I have some values on both sides, don't I? Okay, so that's what I'm going to try and do. I'm going to use values on both sides. So it's slope formula. So I'm going to use this value here and this value here. Because if I just do these two right here, I'm going to get the slope on this side. If I get these two over here, I'm going to get the slope on the other side. But I want to try and somewhere in between. Okay, somewhere in between. So I want to use both sides of there to actually get that. So if I do that, it's going to be 33 minus 3 over 3 minus 1, which is 30 over 2, which is 15. So my slope here is going to be 15. That's a good approximation. Okay, that's of my secant line. Do you guys understand why I use both sides too? Okay. There, we're done. All right, today's homework. Make sure you guys work on it, like and subscribe.